Oh, okay. Tell me, am I writing this correctly? 12 over 1.18. Is that how you do it or no?
1.08 over 12.
Yes, thank you. So it's $1, 1.08 over 12. Let's see what that is. Okay, so here it is, 0.09, but it's going to be dollar per ounce. Is that right? Per ounce. So these are unit price. A unit price, a unit price. You got unit prices. Which would be a better buy? What do you think?
9 cents.
Yeah,
So
you want
$1.08 over
right.
12.
So this is about your making sense of the unit and the price and the problem, basically. So yeah, the unit price that you want to go for is the lower amount so that you can pay less. So it's 9 cents per ounce. There you go. So let's go with that. Very good. This is a good problem, even though it's unit price. You've done this like thousands of times, but it's about your actually understanding the difference. So it's a good problem. I really like it. Yeah, really, really like it. Yeah, big can, small can. But anyway, the cheaper one would be the 9 cents one. All right, next one. All right, ratio of painted faces. Okay, to unpainted faces 3 to 5. Okay, how do you write that before we move on? How would you want to write that?
5 unpainted over 3 painted times 1,800 painted. And you
Okay,
cancel out the unit.
okay, you went ahead there, but yes, that's right. So I'll write it first. 3 over 5, but the 3 is gonna be the painted. So I'll do painted. I want to kind of note that, and unpainted on the bottom. I should be writing elsewhere, but I think it's okay. Unpainted, okay. I'm writing there. If 18,000 had painted faces, how many? Okay, so tell me again, how would I set that up? So I got 3 over 5.
5 unpainted over 3 painted times
Okay,
1,800 painted.
okay. Now, that is correct, by the way. But this time, shouldn't you be setting up an equation for this one? You've been doing that a lot. You want to try and set up an equation? I think they actually want you to do that. Not that the way you said it just now, it's wrong. It's actually something you've been doing for a very long time. But this time, I have a feeling the way it's written that you should be setting this one up as an equation. I'm pretty sure.
5 unpainted over 3 painted times 1,800 painted equals x. Or
Okay,
x equals.
not quite. Let me show it to you. We should do it this way. I believe this may be something kind of new to you. So I believe this could be it. This is some like, you know, how like they always introduce something new. This, now, even though you watch what I'm about to write is like something you've seen before, but writing it based off a story, like setting it up on your own may be different. Have a look, okay? The reason why I believe this is actually the way they want it is because the way they have it written for the first statement. It goes like, hey, you know, the painted over the unpainted. So I believe they want you to keep this 3/5 as is. And here's what you can do next. Have a look. If 1800 had painted face, how many non-painted? Take a look. If this makes sense to you. There it is. Is that something you're okay with?
Yeah.
This is what they want. I'm pretty sure this has to do with proportion. There it is. This problem is proportion. Each side is a ratio, but this one as an equation is a proportion problem. I'm pretty sure. Later on, every time you come across something like this, they give you a ratio. Sometimes they don't give you the word ratio, but they imply that there's a fraction, something to something or something over something. Sometimes it's like way longer than that, like the first statement. You have to set it up like this. They give you two subjects, and then they give you like relating proportion, relating to each other. And then they give you, hey, what if this one of them is really, really big or small, really, really small? How would you solve for the other one, right? Here it is. So I'm pretty sure this is what they want. Now, I could be wrong. I think your teacher, look, I could be wrong. Maybe that's the thing that you said earlier, what do you call it? Unit multiply. You did a unit multiplier earlier. You mentioned the unit multiplier way. That may be the way if your teacher wanted it. But from what I can tell, this book, this problem is proportion. If your teacher wrote it differently, I think he's wrong. Because you already did this before, the proportion, like earlier. Therefore, this one is going to be it for you to set up on your own, for sure. So yeah, whatever your teacher says, this is, I'm saying, dude, this is the right way. But I think this is what your teacher still wanted. If your teacher didn't tell you already, I hope he didn't tell you already. Anyway, I guess we should solve it. Let me double check. Paint face. Yeah, just solve it. Cross multiply. Is that okay? You remember that? 3x equals 5 times 1800. Now watch me do this, okay? Look, you may be wanting to multiply 5 times 18. You could, however, watch what I would do. Divide both sides by 3 right away. And let me see if you understand why I can do that. Now, you only do this without multiplying the two numbers there. Is if and only if what you're dividing it by you can divide one of the factors. 5 times 18 is a factor divided by like the coefficient number, like the 3. If you know that like this 1800 can be divided by 3, don't multiply it, because here's why. Watch. I just continue like this. Then I cross cancel here. It's easier. Imagine you blow up that 5 times 18. It'll become an unrecognizable number now. But this 3 and 18 is still small enough for you to actually reduce or cross cancel. Look, I'm showing you everything, right? This is pretty good. Pretty good stuff. What? Let's see. How many times? 3 can go into 18 6 times, but add the 0. Is that okay? Do you agree? And I'll show you use a calculator. We just give you the same answer if you were to multiply it out. So anyway, I know you agree with me. So here's your final answer. And it's up one time, 30, and then add the 2 zeros left. So it should be 3,000. There it is. Now, do you agree? Yeah, I'll even show it to you. 5 times 1800 right here. Then divide that by 3. Still same answer. Now, I know that 9 is not a bad number, 9,000. What if it were something else, right? But this happens to be just fine. It could be something else that is not like nice, divisible by 3 number. Imagine that. So anyway, this is what I think you should learn to recognize so that you can shorten things or speed things up a little bit. There it is, dude. What is this? Unit? What is the unit? Faces. I just do generic here. Faces. Unpainted? Unpainted. Unpainted, to be specific. But I think you should be fine. All right. Number 3. What is that? 7/8. 7/8 of workers' income has used to pay for necessities. If $5,600 spent on necessity, how much was the workers' income? Okay, what do you think? Yeah, what do you think about this one? 7/8 of workers' income.
7/8 times $5,600.
You want to think about it again?
7/8 equals 5,600 over x.
Okay, so this is actually not a proportion problem, but it can be kind of like arrange it in a proportion. But I don't recommend you do it. You want to kind of like reset. Yeah, forget proportion. Kind of reset and kind of make sense of it. Start again. Yeah, let's see. Yes, start again and see if you can make sense of it. 7/8 of the workers' income was used to pay for necessities. The word necessities is this related to this price, this 5,600. What do you think? 7/8, 7/8. So, and it's asking for the income, right? 7/8 of the workers' income. Remember, a fraction of multiply. Do you remember that one? I'm sure you do. Like fraction of anything, it's multiplication. But do you know like how much? Like, do you know the word income? Do you know anything about relating to the income? You don't because it's asking you for it, right? So, what do you think? I'll let you think about it. Don't worry. This one is like, yeah. So let me back here so it looks. I'll let you read it again. 7/8 of the worker's income. We don't know that. We don't know the income. We're looking for it. Was used to pay. Used to pay. That's equal. If if you want me to give you the hint, that's equal for necessity. For necessities.
7/8 times x equals 5,600.
Yes. Okay. Now do you see it? Yeah. That's it. Yes. You can assign or declare the variable. Let x be equals how much or income. Just say income. Is that okay? Yeah. To make it short, income because you're looking for that anyway. Income. The income equals 5,600. There it is. This is how they want it. All right. I know you can solve this one, but we'll come back for it. Oh, you see, I'm pretty sure this is exactly what they're leading to because later on here, but I know you've seen this all the time anyway. Like, no, number 8, without any story behind it. Number 7, number 8, number 9. It's like that anyway. So there it is. Number 7 is literally exact same arrangement as number 3 that we just looked at right now. But okay, anyway, I think you can see what's up. So anyway, that's it. But let me see. Any kind of fancy work? Yeah, flip flop, multiply. I mean, I know you know how to do it, but let me have a look at it here. Yeah, 7 can go and look like right here. Yeah, try to do this cross canceling anywhere you can, okay? Because it's possible here. So put a 1 underneath. 7 going to 56 8 times, but add the 0. So it's 800. And 8 times 8 is 64. Add do the 0. There it is. So the income is going to be $6,400. Check my math. Is that okay?
Yeah. Yeah.
Yeah, I'm sure. Oh, you punch in the calculator. You want to see it? What is that? 56 times 7 divided by 8. Wait, I hit that in wrong. I think. 56 87, not 7 8. See, 600 times 8 divided by 7. I should parenthesize that, but anyway, it's over operation. 87. There it is. 6,400. Okay, next one here. I think you're good with this, right? Converting. This is so great. Again, yeah, that you're getting practice over and over so you don't forget. 37%, 37 over 100. Okay, it's not reducible. Okay, what about this one? Oh yeah. Let's. I know you got this one too, but it says round this small, really small number to the 10 millionths place. Go for it. Then we'll continue with it later. Let's do this first.
Uh,
Yeah,
so in
10.
million.
Want to go along with me here? Tenth, hundreds, thousands, 10,000, 100,000, 1 million, 10 millions, 10 millions right there. This is 10 millions right here. Is that right?
Yeah.
Then 100 millions right there. and then a billion over here. So how would you round it? Double check if you want, okay?
Zero
Yeah,
point
it's
zero 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 916.
9 1 10 million. Okay, let me check again. Yeah, I haven't done this for a while, right? See, that's why it's such a good number. Tenth, hundreds, thousands, 10,000, 100,000, 1 millionth, 10 millionth, 10 millions right there, 10 millions right there. 100 millions at 5? Is that right? 100 millions?
Yeah.
So what did you say? What did you say the rounding was?
So
So 10 millions is at the one digit right there, so I'm kind of pointing to it. But this one right here is 100 million.
so it'd be 0.00000092.
9 2. I believe that is the answer. Is that okay? Because you look at where you are, but you look one behind it. You look at where they want you to look at, and then you one behind it. And then one behind it is actually 5 or greater, then you have to go round it up. So here's what I think it's right here. Yeah, we haven't done this for a while. That's why we're picking it. See how many zeros? 5 zeros, 9 2. Okay, I think that's right. Oh man. Anyway, write the rounded number in sign. Now we're not done. Now we're going to use this number and write it as a scientific notation. What do you think?
So you have to put the dot in between the 9 and the 2, so you have to move to the you have to move it 6 times. So it's 9.2 times 10 to the negative 6.
Yeah, that looks good to me. Okay, you got it. Yeah, the top part, I guess, right? You haven't done it for a while. It's the rounding part. Yeah, it looks good to me now. All right, I believe these are right. So we got the first part done. The second part here. Yeah, you got to show both of them. But anyway, I'm sure they're good. I know it's like, man, I was like, wow. The other one is more technically supposed to be more challenging. But yeah, I'm pretty sure it's good now. The rounding one, man. All right, number 6. Let me see. There are, what is this? There are 300. I'm sorry. There are 130 mountain bikes in the Ike's bike bicycle shop. Try to say that. Ike's bikes bicycle shop. If 50 of the mountain bikes have bar ends, what percent of the bikes have bar ends? Draw a diagram to help solve this problem. I don't know what that diagram looks like, but what do you think?
We don't have to draw the diagram.
Okay, cool. But okay, but how will you set it up?
So
So I'm glad that you don't have to do that anymore. Okay, so there are total, the way it's implied, like the total number of bike is 130, right? 50, 50 of them are mountain bikes that have bar ends. What percent of the bike have bar ends? Yeah.
so you do 130 divided by 52.
130 divided by 52. That looks like this. Is that what you said? Like, or do you want to divide? Like, do you want to divide by 52? Don't forget, this is about percent. Think about it, okay? Percent. Normally, when you want to get percent, you have to have like a regular fraction, and then you convert that into percent. If you if you do if you do this, it will look like this as a fraction. Do you want to use that? Right? Remember, like this. Yeah, this is about percent. What percent? Right? This is about coming up with the percent. Normally, when you come up with the percent, you'll have a number that it's like you have a fraction or a decimal number like this one up here. But this is actually a mixed number. It could be, but do you think that's right?
No.
What do you think?
Wait,
There are a total number of 130 mountain bikes. 52 of them have bar ends, and they're asking for the percent of that type of bike that have bar ends. That's all.
um,
So yeah, you don't want to divide that total. It's a total number of bikes, right? And there's 50. Out of that many bikes, there are 50 that happens to have like the bar ends. And then what is the percent of that, of the total? Yeah, what do you think the setup? It's supposed to be easy, but I know. So you've done so many harder stuff and like, okay, so it's 52 over 130, dude. That's what you're supposed to do. But you have to convert that into percent. See that?
yeah. So then you divide 52 by 130 to get a decimal to turn into a percent.
Yeah, but before, yeah, that's yeah, you can do it different way too to get the percent. But yeah, that's a normal way. But is that okay, dude? This is what you do because it's like this many out of that total. This many out of that total. What is percent of that many? You know that whatever they're asking. Yeah, I know it's just worded. It's like sometimes it's confusing. I don't like it. It's like they're decoys, like the bike's shop name. Try to say that. That's a decoy. That's like slow you down, like get you confused. But basically, they're implying that hey, the total number of bikes is 130, and the 50 of them is what is the percent of that 50, right? That's it. So that's how you do it. Now, there's a trick here. I mean, yeah, you'll be doing long division, but it's long, dude. But don't forget, if you do it, it has to look like this. The divisor is your denominator, right? You got to do your math here. But there's a little shortcut here. If and only if you recognize it, I don't think many will do. 13 can divide into 52, dude. I don't think you would know that, but it does. I recognize it, but that requires experience. But let me show it to you. Shoot. Yeah, 52 can be divided by 13. How many times? Now, then what will you do with that? Look at that. You see that? Four times. Then what are you going to do with that? Here's what you can do. Watch. I would divide this by 13. Divide this by 13. Now you don't have to do this. You should be doing this. And I think maybe all of you guys will do it. The whole class will probably do the long division right off the bat like that. But if you want to kind of like do a little shortcut here, you can. If and only you know that 13 can divide into 52 four times itself one time. And that's what I'm trying to do here. So if you do it right, it will be 4 times you saw in the calculator, and here 10 times. See that?
Yeah.
From here, it's easy. 4/10, dude. 4/10, 4/10, 4/10, 0.4. That's 4/10, isn't it? The answer is 40%. Done. See it? Now, I mean, I don't expect the student to know that 52 can be divided by 13. Therefore, you have to deal with the long division. But from here on, I think you can kind of like look, like eye it. Is that can? So they write this thing actually on it on purpose to see if you want to use it this way or that way, right? So that's why this book is good. Normally, this would not be it. That 52 likely going to be 51 or something else, not divisible by 130 or the 13 portion of it. So whoever wrote this, it's actually quite good. That's why I'm praising this over and over. This book is actually well written. So you may not think much of it, but trust me, it's a good book, good practice, repetition, and everything. Okay, I know we're spending too much time here, but okay, I know you can do these ones, but we'll come back if we have time. I want to look at the cool heart shaped problem here. What do you think?
So
The dimensions are given to you. A, find the perimeter. Wait, how do we find the perimeter? For A, find the perimeter, and B, area. Wait, am I looking at the right problem here? Okay, yeah. So, yeah, sometimes nothing is perfect here. I believe that the perimeter will be relating to this one right here. Help me out. And B will be, what do you think? B,
the
yeah, they're
area.
saying on the left. That means you do the perimeter and area of this one right here on the left.
Yeah.
This is not that great. They could have split them, but they save space if they, like this. 12, then you do the volume. Then you do the volume for 12. So it's 7-inch high here. Is that okay? I don't know
Yeah.
what I'm writing there. Okay, so it's 7. I'll write it right there. 7 inches. Okay, so find the perimeter of this thing. How would you do it? What do you think?
So you have to so for the square it'd be 20 times 20.
We doing perimeter or we doing area? What do you think?
Or
Should,
perimeter. So
okay.
we'll do 20 plus 20 plus 20 plus 20.
Okay. Now this
Or
is
20 times 4.
actually careful. Okay, if they say perimeter, you're not gonna have to account for those lines there. See, you have to work all around it. Yeah, you don't include those dashed line, dude. You got to work all the way around like this only. Want to try again?
So you have to do 3.14 times 10.
3.14 times 10. Just that. But watch it. If you times 10, you want to parenthesize it, okay?
Yeah.
And what else? Now, are you sure? Double check. Circumference, there's two formula. One is 2 pi times r, and the other one is pi times diameter, circumference of a circle. So what do you think?
Um,
So I assume you're getting this arc and this arc first.
yeah.
Is that right? Okay.
So since it's 31.4 for both of them, uh, you add 31.4 and 31.4,
Actually, no.
and
Wait,
then
before you do, this number 10 is not correct. It's not just 10 because you,
or 5 or 20 or
20.
100 because it's 10, 10.
No,
Yeah.
no, not 100 because if you do 100, that's when the area, that's when you do area. We're not doing the 100 yet, right? If you do,
So it's 20.
yeah, the 100 will be squared. Yeah, 10 squared will be, yeah, it will be 20. So you have to do a 21. Therefore, you're using this one right here. Is that okay? Using that
Yeah.
circumference. Okay. So what is that? Oh, but let's continue before we do it. Let's do the whole setup. Yeah, let's do the whole setup. So we got this out of the way. We need the rest of it. By the way, is that okay that you do this for both of them at the same time because it's half and half? That's the whole circle, right? So
Yeah.
we're good. We're good with that. Those two arcs. But then we need this right here to complete the perimeter.
um.
Right here and here, right? Yeah.
Yeah. So it's
Plus,
tw- 20 40.
Let me see. Is it 40? Yeah, because this long is 20, right? And this long is 20. Am I right?
Yeah.
Yeah. So it's plus 40. That's it. Whatever that is. That's your perimeter. Now let's, yeah, hope you're okay with that. Yeah, that looks good. So this is going to be your perimeter right here. What about B? Find the area.
And then it'll be 3.14 times 200 because it's 100 and 100.
Yes,
And
3.14 times 100. But parenthesize is exactly this way, okay? Because you have a decimal number. You don't do a dot, okay? Be grammatic, like punctuation wise. Yeah, do punctuation nicely in math. Don't do a dot times 100. Put a parenthesis. So, okay, that's going to give you the area of the circles, the two of them together combined. Is that okay? Like that? Halves and
yeah.
halves? Yes. And then what?
And then 20 times 20.
Yeah, that's it. 20 squared. That's it. Whatever that is for the area. Perimeter area. Is that okay?
Yeah.
That's your, yeah. Okay, 12. How we do 12? It's going to be the volume for the whole solid, the heart shaped
Oh,
box.
yeah. And then we take the area of it, so 3.14 times 100 plus 20 squared times 7 inches.
That's it. So careful on this one. I would get the answer and then the answer from here, entire answer from there, and then times it by 7. If
Yeah.
not, you have to parenthesize it. Is that okay? You have to group it. Yeah, yeah, be careful here. So let me see. It's punching the calculator. Sorry. So you get the answer at the same time here. 3.14 times 100 plus 20 squared, which is going to be 400. So it's up here, okay, it's 714 for the area. Write the unit carefully. This is going to be inch squared here. Oh, that's okay. Double check. Yeah, 714. And then over here, you do 714 times 7. Is that okay?
Yeah.
Times 7. That's going to be 4998, whatever that is, inch cubed. There it is for number 12. Oop, 13. Oh, man. Dyslexic there. I'm sure that's good. Let's see the next page here quickly, just in case there's something fancy. Double check. Yeah, looks good to me. All right. All right, number 13. Is that okay? You okay with that? Okay, 13. Simon Snail slid along at 15 inches per day. Then he got tired and could go only half that fast. Bad writing there. It's the rate. How long would it take Simon to slide 45 inches at the slow rate? Okay, what do you think? So it's 15 inches per day at first. I'll write it like this. So what do you think? He got tired and could only I could go only half that fast. Okay. What do you think?
So it's 15 inches per day. And then you divide it in half.
Yes. What is $15? What is half of $15? What is half of $14? 7, right?
7. So
What is
7.5.
Yeah, 7.5. inch per day. Well, I'll write it as a fraction this time. Inch per 1 day. Is that okay?
Yeah.
Oh, how long would it take? How long? That means I think that's days, right? That means I'll flip flop this here to 7.5. And then what do I do with that?
And then you have to. Oh, and then you have to. Yeah, so it's you do 1 day over 7.5 inches times 45 inches, and you cross
Yeah,
out the inches. Yeah.
that's it. So whatever that is, and multiplies. So it's 45 divided by 7.5. Yeah, this is not a well-written problem because here's why. It seems like it's actually happened in time, like Simon Snail slid 15. Where did that happen? What about how long did he go for that, or how many days, like for the first statement? So that's all of a sudden that's like neglected. Get it? So it's not well written because it neglect the 15 inches per day. So it's like whatever it is, we don't care for it. How long would it take at that slow rate for 45 inches? So whatever. So we just go with what they ask. Yeah. So they neglect partial. They only have you do partial of the problem and neglect the other part, like the beginning part, 15 inches per day. What happened to that? How long did it go for? We don't know. It doesn't say. Then got tired. Yeah. Then got tired and then go only have as fast. How long would it take Simon to slide 45 at that? See, we don't know. So we only know the last part, I guess, like the last 45 inches. It makes no sense to me. But okay, they're just trying to make you follow the instruction. So I think number 13 is about you following instruction, but it's not that great to me. But anyway, overall, this book is good. I know. All right, find the surface area of this right solid. Oh yeah, so let's look at this quickly. And then I think you may be okay. So tell me how to do this here. So the tent, you have to find the surface area of the tent. Now imagine the back side, the other side of it, all of that. So what do you think? Let's do it. 14, okay? Let's set it up. So let's do the front triangles first. Is that okay? It's up to you.
You do.
Front and back. I guess the front triangle and the back triangle here. Back there.
Would it be 3 times 2 divided by 2? So
3
6 divided by.
3 times 3, yeah, 3 times 2 divided by 2 for the front. Is that okay? Yeah. 3 times, yeah, base times height. That's correct. But let's do the back also. Times it by 2.
Mm-hmm.
Is that okay? Put it in the front or in the back. Doesn't matter. Plus what? So we got the front and back.
Plus 3.16 times 6 times 2.
Yes. Very good. 3.16 for the sides, the two sides, times 2. Parenthesize it like this. Have a look. Now I know I put a decimal here to make them bold right there. Careful on that. You can cross cancel that right now if you want, so that you don't forget. Cross cancel that. You're left with 6 here, plus whatever this is, 6.28. No, 38, whatever that is, times 2. Wait, 3.4. No wonder I got confused there. 3 point. Oh, no, 3.6. That's right, 3.16. I keep thinking pi, whatever. 3.16 times 2. So it's
Isn't it
6.32.
times 2 times 6?
Let me see here. Okay, ignore my math. So I only got 6, okay. Let me see, you got times 6. Thank you. Times 2. Or times 2 times 6. Is that okay?
Mm-hmm.
Yes. So we're finding this by multiplying this and this, which is the length and the width, 3.1416 also, and then times it by 2 because there's another one on this side
Yeah.
here. I think that's it. That we should not
And
account for
then
the bottom. Wait, we should not account for the bottom. Oh, the 10 do come with the bottom, right?
yeah,
Yeah, right? Yeah. So what's the bottom part?
6 times 2.
Yeah, that's it. 6 times 2 because this is 1 plus 1. So 6 times 2. Okay. Whatever all that is together. Is that okay? Dot, dot, dot here.
Yeah.
Okay, you got this, dude. Yeah, yeah, you're right. The 10 does have the bottom portion so that you don't get dirty when you sleep on it. Okay, everything else you should be fine. Okay, wait, one last one quickly, okay? The we have to set up the proportion for the triangle here. There's similar triangle, but it's tilted weird. Let me see if you're gonna get this. It's flipped.
So
Careful.
it's A over 2 equals 5 over B.
A over 2 equals 5 over B. A over 2. Nope. Ah, yeah, they got you on this one, dude. Look at it again. They rotate this weird so that they're trying to trick you. They rotate this or it doesn't matter.
Oh, yeah,
Yeah,
yeah, yeah.
so go
So
again.
it's 3.5, or A over 3.5 equals 5 over 2.
Okay, now I know that you shortcut this. The reason is
Or
you
3
you
and
have
1/2.
yeah. Let's do 3 and 1/2. The reason why because you're also gonna have to solve for B. You know what I'm saying? So you have to use that
Yeah.
number. Yeah, this one is gonna repeat like 0.6666. You don't want to use don't round the answer. You have to convert into improper fraction. Yeah, get all the exact answer. Is that okay? Yeah, do your math. Don't round anything. I know that you can do a decimal on this one, but this is going to be 10.66666, 6 bar. Can't do that. You're going to have to convert and do everything accordingly. So okay, A. Yeah, you're right. You got. Let me see. You got A over that, and then what's the other one? The fraction.
And then 5 over 2.
5/2A. Yep. Big to small. Big to small. Yeah, that looks good. And then what about B setup?
For B,
Mm-hmm.
it's 10 and 2/3 over B equals uh, uh, uh 10 and 2/3 over B equals
Isn't it the same? 5/2.
5 over 2. Yeah, 5
Right?
over 2.
Yeah, because you use that number as a pivot. But don't forget the way you did it. You went from large to small. Is it okay? You went this way,
Yeah.
large to small. Yeah, it works for me. Yeah, but when you do the math, I recommend you convert into improper fraction first and then cross multiply. Is that okay? Like whatever this is times 5, A times 2. Improper fraction times 2 here and 5 times B. Is that okay? Yeah.
Mm-hmm.
All right, dude. That was good. I like it. These are like, they're like tricky ones and new ones, challenging ones. I'm glad.